Aslam Khan.
Thank you. Good morning. I'm going to test if there's any family in the audience. It's a new test. I've never done this before. Manjla. Okay, there's no South Africans here. Okay, so I'm Aslam. It's good to be back from this country that's formerly known as South Africa, but now known as a shithole. So good to be here. Um, I added this quote quite recently: "You live and learn. At any rate, you live." It's inspired by a young man here in Sweden called Timo in the corner. He was doubting whether he should spend a Saturday to learn. And so I said, well, you could just live, right? So anyway. I haven't spoken much in the last few years. And I was thinking, why haven't I spoken? And I thought, well, I'd got nothing much to say. And then come December last year, I realized that I'm exhausted. And if you're exhausted from doing absolutely nothing, what the hell have you been doing all this time? You're just living and not much learning going on. So I'm going to throw some stuff out today that I've been mulling and trying. So it's not a gospel, it's nothing like that. I'd love to get feedback from you in conversation, in tweets, in any way possible. And for you to critique what I'm talking about. I've gone and thought about what we actually do. And I've simplified it. On one side, we have a problem, or assume we have a problem. We have lots of conversations, we draw some stuff, sometimes we sketch on a whiteboard, sometimes we sketch in code, sometimes you sketch in things called enterprise architecture tools. And somehow it ends up as code, and that code gets run, and hopefully that running code gets used. And in a very trivial way, perhaps, that's what we actually do. And it feels linear, but this is what I understand it to be. At some point, we're trying to understand, and at some point, we're trying to apply our understanding. And depending on your certification, you call that observation something else. I was going to say religion, but religion doesn't have any feedback loops. So based on your observation, sorry, it's a bit early, shots fired. I'm in that kind of mood today. So we realized a while back, and we've gotten better and better at doing this. That is, observe what is actually happening and make some adjustments, and so try to make it better. It's impossible to try to understand everything up front. We know that. It just doesn't fit in our collective heads. It ends up being used and run, and then we learn from that and try to adjust and make it better. We also do this. We fix mistakes, which means that what it does mean is that we're fallible, we're humans, we make mistakes. It's absolutely okay. Sometimes it's because it's been late at night and you didn't pay careful attention and it's an off by one, like blockchain. But I think of it like this. There's two very distinct parts. We're fighting this thing of complexity all the time, and we all stand and wave flags about simplicity and things. But in that part where we're trying to understand, it's dominated by the complexity of the domain, the thing that we're trying to understand. And the moment we throw in these feedback loops, we're actually dealing with what to do with that change that we need to apply. Yes, it is still about the domain, but what dominates is how to incorporate that change. And so I tried to make sense of it by myself, to say there's two very different natures to that complexity. The one is inherent, that is, it's actually part of the domain. It's never going away, right? It is just part of it. It's there. So you got no choice but to bruise your nose, bump your feet, and try to make sense of it in the best way possible. The other one is nasty, because if you take your eye off, those changes are happening, those effects are happening whether you're paying attention or not. And then it sneaks up on you, and it bites you. And it's gradual. It's not necessarily instantaneous, but it is a kind of change. It's a kind of complexity that comes from dealing with change, and sometimes we try to put our heads in the sand like ostriches and pretend it's not happening. It's one technique. Doesn't work very well for a long time, but it works for a point. So when I think about it, I said, well, if we're dealing with inherent complexity, then we actually need tools to understand. And if we're dealing with what I've been calling insidious complexity, it's perhaps an overloaded emotional word, but it's tools for noticing change. We do have tools for incorporating changes, and we're getting better and better at that, but do we have the right tools for noticing change? And so I've tried to separate them out in those ways. And I try to, when I'm working, figure out whether I'm here or I'm here. So if you want to avoid that insidious change, you just don't take code to production. It's fine. Just keep on living in a bubble for those projects that never get authorized into production. It's fine. So it's only for those of us, this talk is only for those of us who actually have code in production. And we'll deal with that. So I've been thinking about what are the tools that we use in that inherent complexity part. Guys familiar with some of the domain-driven design concepts and principles? So ubiquitous language comes from that body of work, and it says that we should adopt a vocabulary that goes from conversation to our lines of code. And let's be consistent and make decent sentences in code, decent sentences in conversations and in diagrams. And that's what we call a ubiquitous language, and it's actually incredibly powerful. And if you do nothing else and just do that, it'll be good for you. There's also patterns, there's test-driven development, and there's refactoring, and I guess there's a few other things as well. But those what come to mind as the dominating tools in our toolbox. And we're getting better and better at using it. Like all tools, sometimes we abuse it, or use it in the wrong moment, in the wrong context, but that's not the fault of the tool. It's actually an incredibly rich tool set. And so there's nothing wrong with that, and we should continue doing that. On the other side, that part where we draw things and sketch out stuff and then we make code out of it, we're still leveraging off ubiquitous language, patterns, TDD, refactoring. And then we have this notion of continuous delivery, continuous integration to continuous delivery, which is as I make changes, build it, test it, and automatically deploy it or provision environments. And take it all the way to run. And so that is already, that notion of continuous delivery has been a way, it's allowed us to work in a different way in the last few years. And in a very incredibly powerful way, because it makes that feedback loop a lot tighter. And then we realize that the more frequently we can propagate a change into a run environment, the better it is for us. So those are the tools, and if I put them together, that's what we have. And so what do you notice? It's pretty concentrated around code and how we work with code. As software developers, testers, analysts, etc. It's very, very concentrated in that part. And rightfully so, because we generally suck at that as well. And so we all wake up and look at the code the next day and says, what the hell was I doing? And 2 years later, it's on your epitaph, on your gravestone. It's like the worst lines of code you've written. But it's there, right? It just degrades because our understanding changes. We learn more, and so it looks worse, right? So rightfully so, we have given attention to that part in the middle. Absolutely rightfully so. And so I'm not saying we should stop doing that, because if we stop doing that, it gets worse. But we need to get better on what's flanking it. And also here, that part. I used to say for a while that your design is one use case away from being invalidated. Just one scenario, and you might think, oh damn, didn't see that coming. And that's okay. And so I started thinking about that a bit more, and I says, well, perhaps the problem is that we don't articulate the problem clearly enough. There's still a high degree of ambiguity, and I'm not professing that you attempt to eliminate all ambiguity, because sometimes we need to live with that ambiguity and work through it. But sometimes I think we're too hasty by assuming what the problem statement is, and we rush into building something, and then we realize, oh, we're building the wrong thing. And that's the worst possible feeling. So we've got tools for code, and what are we going to do with the other stuff? And that's what I've started thinking about, the work I've done in the last few years, and what was in that I could perhaps distill and share with you. So I want to pause for a minute and obfuscate all names and hope I'm not breaking any non-disclosure agreements and things, and just simplify it a bit. It's an organization I've been working with for a while. And let's just say they offer loans, and in their market, they're in the top 5, which is pretty good in quite a dense market of players. And like all good organizations, they want to be number 1. Nothing wrong with that. Nobody says, well, let's be number 2. That'll be good, right? It just feels wrong. So they want to be number 1. But they said that what's obstructing them from being number 1 is that it takes too long to approve loan applications. And people go to their financial advisors and brokers and etc. and apply for a loan, whether it's for a vehicle or for some expenditure or something like that. But they apply for a loan, whether it's a home or something like that. And they say it takes long to process that, and that's why they're losing out. And why does it, and as a good citizen you ask why, you say because our workflow is too rigid. And it sounds all reasonable. And so, as a good software developer, you get all excited and you recognize, oh, it takes too long. The workflow sucks. Let's go and inspect that. So what do you want to do? You want to map out the workflow. What are the different scenarios? Let's visualize the value stream and ask what is making it slow. And those are all legitimate questions and approaches. They genuinely are legitimate based on what we observed and heard in the conversation. But let's look again, right? And they actually want to be number 1. They're telling us a problem about running, not what's at the beginning. I want to be number 1. So I tried to pull up and say, what is this thing about being number 1? What does it represent? And so the first thing I asked was, or questioned of ourselves, was that, can we achieve being number 1 by fixing those 2 things? If I made it a flexible workflow and sped it up, will you become number 1? Will that shift the dial? Like seriously, will it shift the dial? And we weren't sure, because it was a provocative question. But you look at the nature of what we're talking about. We're talking about the outputs and the inputs. And what I've learned in the last few years is that start with the output. Absolutely focus on the output. Understand what it is that you actually want. We tend to lean towards the input because it's close at hand and it is something we can grapple with, and we have the tools and the questions and the way to have conversations about the input. But we actually don't know whether that set of inputs actually has a material effect on the output that we're after. It's also incredibly hard to talk about an output that doesn't exist. It's really difficult because you're asking people to imagine a state. And that state is perhaps intangible. And so the output is you want to be disruptive, you want to be number 1. You believe that the input is your workflow and the time it takes to process applications. So if you want to focus on the output, you need to challenge what the state is right now, because you want to know where you're at so you can go to somewhere different. So we just started looking at this, and I've simplified this and looked at some data that exists, readily available, and said, well, how many loans do you get? How many are applied? How many are approved? And how many are accepted? And you ended up with this double slope. High decline from applied applications to what gets approved. And approved means that we're happy to lend you money. We'll make you the offer. Then you decide whether you want to take it up or not based on interest rates, etc. But there's huge decrease. And the question you ask yourself is that legitimate? Is that normal? Because in the business of loans, for example, you don't want to give a loan to any person. You need to be pretty careful that they are able to pay it back. And there's laws and regulations that says you shouldn't be nasty and give people loans they can't pay back. But there's also this other slope that says that even though we approve you, some of you go away. Why? So the question that you want answered is that what is the output that you actually want? Do you want to reduce the number or increase the number of approvals, or would you like to get to a point where all approvals are taken up by customers? And so by focusing on that output, using actual data to tell a story, you come up with some clarity about what is the problem you're trying to solve. And so the question then that is next is, what must we change in order to achieve that? So this is what we've done. We focus on the output, we use actual data, and we can surface inherent complexity with greater clarity. So we're trying to remove some ambiguity and give a starting point. The nice thing about using the data is that it's tangible, it's visual, it's accessible. In this particular case, when we worked with the client, they said, well, we don't believe that. He says, well, it's your data, you gave it to us. No, it's not. Yes, it is. And so it creates far more powerful conversations than something that's completely speculative. So I have at least one way. That is, focus on the output, not the input. And I end up using this quite a lot these days, which is what I call output modeling, which is always have conversations about the output, and then you'll figure out which inputs actually have that effect or materially affect that output. So let's just say now we've figured it out, we want to do that. That's the desired output. That business of too long to approve and rigid workflow, we can't ignore it. The question is it still an important part of the inherent complexity? Is it something that's important? And the issue with those kinds of statements is that you don't know whether it's fact, you don't know whether it's an observation or an assumption, or it's actually a bias of, the loudest person in the room. Up? There? Good? Okay. Do I have to start again? Very good. All right. Okay, so there's a statement, it takes too long, and there's a rigid workflow. The question is it observation or bias, assumption or truth? And that's what we need to figure out. That's our job. Figure out the truth. And the answer lies in data again. So we pop the why stack. My alternative to the why stack is tell people, so what? Right? Like, why? Yeah, so what? What does it mean? So it's the same thing. So it takes too long because it's a rigid workflow. But if you start digging a little bit deeper, it's because there's a lot of manual processing. And why is there a lot of manual processing? Because there's a high rate of exceptions. That is, applications come in, we don't know how to process that using the system that we built. So it gets thrown up and says, whoa, complex case. Eyeballs, look at it, run it on your spreadsheet, and we'll handle it and approve or disapprove it, right, or reject it. So the truth says that there's a high rate of exceptions, which leads to manual workflow. Right? A lot of manual processing. That rigid workflow becomes an assumption, and that takes too long becomes a bias. And so what we want to do is firstly correct the perception of reality with a statement of reality. So on one side is what we believed, and on this side is what we've proven. that what really happens is that there's an inconsistent loan data that comes in, and the workflow rules cannot process that inconsistent data, so it results in a high rate of exceptions. And going up that stack, it results in manual processing, which means that we approve less than we can. And there's hard data to support that. It exists. So we want to talk about that current reality tree. That's the reality. And that's what we want to deal with, not what was speculative. Once you understand that reality to some extent, you're now actually in a position to hypothesize what the future could look like. And so in a case like this, we actually want to increase the number of approvals, and even if we kept the same rate of take up by customers from approvals, we'll still do better. And that might shift us to number one. So what we actually want is to increase approvals, go from manual to automated processing, have a low rate of exceptions, and come up with some consistent data. And that is something that we could actually work with. As opposed to rushing out and trying to come up with an alternative workflow which may have no material impact, because we're focusing on the output. Even when I look at that future reality tree, it is an output based on observation and data that exists. So we're using data to challenge biases and assumptions, and we surface the current reality tree and we hypothesize a future reality tree. It's a hypothesis, which means that we've got to try things out to see whether it's true or not, whether we can achieve that. And so we start going into explorations and experimentations. So that's the other two things that I keep in my pocket or in my toolbox around trying to get clarity around the inherent complexity and try to zone in on the part that we believe is genuinely the most important, the one that has the greatest possibility of having a material impact on the output. So this is where we're at. We believe we can increase the number of approvals, blah, 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 by fixing the data and reducing exceptions. So it does need some experimentation. And that's where we get back to this thing of feedback loops and how do we design those feedback loops. Many cases I see people just assume there's a feedback loop, and it's a naive feedback loop because it just says we'll gather the data and just look at it and decide what we want to do. But it's far more powerful to design that feedback loop. What is it exactly that we're after? And the key to this is designing feedback loops so that you know you're genuinely shifting from what is to what you wish for. And the key to that is make it measurable, right? So in very simplistic terms, we know we need to change something at some point so that we can measure its impact on another point. That's all it comes down to. Nothing more, nothing less, in very simplistic terms. But what if the process is not trivial? If we sat down and analyzed the entire process for every single scenario, it might be quite complex. And now the question is, where do you introduce that change and where do you put in this little probe to measure? Yes, you could possibly do it everywhere, but is that useful? And you could do it quite randomly. And over time, you might find some use in that as well. So you think in the large, find approximate parts of it that says, well, the big chunks are you receive an application, you assess it, you make an offer, the person signs. In DDD terms, you might say those are bounded contexts or subdomains or something like that. But they're nice, cohesive parts. You could hold it in your hand as a cohesive part and talk for a day about it. And so we're interested in that part, not the detail. And if you're going to do experiments, you want to reduce the number of points where you can make the change, or pick one point at a time and play with that for a while. So in our case, we said, we're going to introduce changes here, and we want to measure here, 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 and here. And what we actually were measuring is the number of exceptions. How many exceptions happen when we receive? How many exceptions happen when we assess, when we make an offer, and when we actually sign an agreement? And so simple histograms of exceptions classified according to the way you think is useful uh, gives you a set of pictures or visualizations, again, based on data. And that's the exceptions that you have. So now you know what you're playing with again. The next time you make some changes to the code and you build something else as a feature, you're expecting to see a change to those exception histograms. And you can do the guessing game. You're hypothesizing. I expected that to come down and that to come down. And sometimes it does something that you didn't expect. And now you can have a very powerful mechanism or powerful point of focus. Wow, we made those changes, we deployed it, it did that, didn't see that coming. What the hell happened, right? So that becomes the way you think about building in those feedback loops. Again, based on data. Because we don't know, it becomes a heuristic-based approach. We kind of feel it's in this place, we're not exactly sure. And so let's use some heuristics, let's build it in. And so you're always playing with that. And so we use that kind of approach to notice if there's insidious behavior in the work that we have done. The most horrible thing is to write software, put into production, not realize its effect over time, and it still continues running, and then you try to fix it, and then we call it legacy, and we have all sorts of metaphors and all sorts of analogies to talk about it, and technical debt and all sorts of things. But the ability to observe that change as soon as possible is an incredibly powerful tool to be able to predict what your next step or choose your next step in what you want to play. So this has a material effect in the way you organize your work. And this was a complete mess up of people's minds because they were Scrum certified and they had a backlog. And there were really nice stories. And there was to do, doing, done. And now we're saying, well, that story that's on the top, it's not at the top anymore because we have data to say that that last story we played that went into production actually had this unexpected consequence, so try that. So it becomes quite a powerful way to have a conversation about priority and where you should be spending time and effort. And again, fashioned in data. So, got tools for code in the middle that we still continue using and doing, using output-based modeling to get some clarification of where we want to go, getting rid or challenging biases and assumptions with data, and on the other side, using some kind of heuristic-based measurement of the effect of your changes to code. Does that make sense? Well, I lost you. So that's the tools that I've been using. The interesting thing that comes out of that is that it's code flanked by data. And I think we've lost the art of working with data. And we've forgotten about it. And so I'd like to see us genuinely giving a lot more attention to data and telling stories with data, because we also tell stories with code. Adam, who's coming up next, is great at telling stories about code, but it also comes up as data again. And so I realized that in the last few years, I've been entrenched more in data than in code. And you do write code, but it's in the interest of data. And so to do that kind of analysis and stuff, it's not months and months. It was a week or a week, 2 weeks to get that frame, that big picture of being number one. What does it mean? And you're writing some Python scripts or R or even Excel to actually get those pictures. Just be wary of not taking what we call a teaspoon sample from a giant pool of data. You might get it wrong. So why data first? And that's the way I think about things, is that let's go with data first. Let the data lead the way. let it lead the charge. And it's about, the thing is that when we talk about software, we do a lot of hand waving, right? And people only understand it when you start drawing a user interface or we draw some boxes and lines, but they actually don't know. And we lose them along the way. However, data is this interesting thing. It's something that you can easily visualize and visualize in very interesting ways. And it becomes something tangible. You actually can stand and point at it and have a conversation about it and talk meaningfully about it. And there's a powerful conversation that comes with that. And so it helps us make better decisions based on facts. A friend of mine told me that, and he's a lawyer, and he says that, yes, I do have lawyer friends. Um, and they are actually nice people, some of them. Uh, he says there's an internal consistency of truth. Forget the data part. There's an internal consistency of truth. That is that if you are trying to tell the truth, it's actually trivial because there's a natural internal consistency. If you are talking a lie, you have to do an incredible amount of work to make the lie consistent. I said, hey dear, yes, I'm on my way home. I was at work. It's like, but you're in the pub. Yeah, I was with John. Yeah, okay. John, when my wife phones, tell her I was with you at the pub. And then you got to bring out a receipt from the pub and things. You do a lot of work to try to create consistency in lies. But there's a natural consistency in truth that is absolutely trivial and wonderful to work with. And the truth of building software lies in the data. So let the data tell you the story. And you get the natural truth. And it helps you avoid, we'll still get things wrong, don't misunderstand me. Because working with data is subject to interpretation. And so there is that. But it works out a whole lot better. That's what I found. This is what I'm playing with at the moment, is that let's stop measuring projects and success and progress with how many story points you created, or how many tennis balls and basketballs or cabbages and broccoli that you estimated with. How many of those? No, not interested. The problem is that we've always measured progress, and we report progress previously with Gantt charts, then with burn down charts and burn up charts, which are Gantt charts on a different axis. But the actual measure of progress, of impact, is what's actually happening to the business. Are we materially shifting them towards being number one? And so we want to talk to those kinds of pictures, the histograms at the bottom. Are we genuinely reducing the number of exceptions? And that is your sense of progress. Because if you're not eating into that problem, you've got zero progress. What we're actually talking about is that we're thinking about operational systems, not just software. And we kind of get into this blinkered view of just working with software and code, but flanking that is data. And there's a whole bunch of stuff that goes into making this thing an operational cohesive unit that is actually meaningful to the business. And so we are talking about your architecture, your design. You're talking about people, and you're talking about communication. And what I've learned over the last few years is that if you resist Conway's law, you will be slain. You will definitely be slain, so gotta embrace it. And the way I start thinking about it is that, what is the structure that we're trying to build? Some of it is software, some of it is how we configure people around working with that software, and how do we allow them to have conversations. So the structure that we genuinely build must generate dialogue. If it can't generate dialogue, it's a horrible structure. It's as simple as that. If you draw it and you can't speak about it, and it has a structure that's hard to talk about it, we need to find a way to talk about it or change the structure. So there's two things that go together. There's an internal consistency of truth that a friend of mine taught me. And there's one from Paulo Freire which says that if the structure does not permit dialogue, the structure must be changed. So if it struggled to have conversations about it, then let's change the structure. And that applies not just to software, but just about everything in life. And so we have truth, we have structure, and we have dialogue. and they work together. And whether you're building software or you're trying to figure out what's the next thing you need to do in your life, you need to work with the truth because there's a consistency. You need to figure out the structure, and can you have conversations with that structure? And if you're trying to change an entire society or political system, it's exactly the same thing. And embedded in that is something that helps you along the way, is that you've got to have a sense of struggle. It's never going to be easy. You're going to get a bloody nose, but there's a sense of struggle that comes with that. You've got to know your history, which is about the data. And you've got to have some humor. Otherwise, you're going to die. Well, we'll all die, but not today. So those three things, at a very meta-philosophical level, I'd like to leave you with. And the fact that let's think about data and use it more powerfully to deal with inherent complexity and the insidious complexity. So after all of that, it still sucks. That's our job. Thank you very much.